Today's topic is rate of reaction and factors affecting rate of reaction of chemical kinetics. Rate of reaction. We can define rate of reaction as the decreasing in the concentration of reactants or increasing in concentration of products in unit time. I am repeating again. Rate of reaction can be defined as decreasing in concentration of reactants or increasing in concentration of products in given time. So we can equating the reaction rates in terms of reactants and in terms of products as I have represented here. Next, the most important thing is the factors that will affect the rate of a reaction are temperature, surface area, concentration, catalyst, chemical nature of reactants, state of the reactants. Here, state means we have to consider as physical state. I am repeating again, the factors that will affect the rate of a reaction are temperature, surface area, concentration, catalyst, chemical nature of reactants, state of the reactants. Now let us see how these factors will affect the rate of reaction. Here the first factor is concentration. In case of gases, that means if gases are reacting molecule, pressure is to be considered. Here, as concentration of reactants increases, the rate of reaction increases. Repeating again, as concentration of reactants increases, rate of reactions increases. Concentration increases means number of reacting molecules increases, then the number of reactant molecules involved in collisions are increases, so the chemical change takes place as soon as possible. And the second one is surface area of reacting molecules. Especially, it is more significant in case of solid reactant molecules. Here, this is also to be considered as size of solid particles. If the size of solid particles is decreased, there will be more surface area available for collisions to occur. This causes increase in rate of reaction. The third one is temperature of reactants. The temperature of a substance is a measure of the average kinetic energy of the particle. The higher the temperature, the faster the particle are moving, which will increase the chance for collisions. This is cause for increase in rate of reaction. The fourth factor is state or phase of the reactants. Here state means we have to consider physical state. The state of the reactants will affect the rate. The relative rates are represented. If the reactant molecules are in gaseous state, the reaction is fastest. If it is in liquid state or solution state, the reaction rate is fast. If it is solid state, the reaction will be somewhat slow. Fifth factor is nature of reactants. That means the chemical nature here. The type of reactants will be determined the activation energy needed to break the bonds and form the intermediate state called the activated complex. The higher the activation energy, the slower the rate of reaction. Endothermic reactions much slower than exothermic reactions because they tend to have higher activation energies. Here, let us see chemically the compounds can broadly classified into two types, that is covalent compounds and ionic compounds. In covalent compounds, energy required for breaking bonds is more. In ionic compounds, there is no need of energy because there is no directional bonds in ionic compounds. So, the rate of reaction is less for covalent compounds and the rate of reaction is more for ionic compounds. Sixth factor is presence of a catalyst. A catalyst works by providing an alternative pathway for the reaction which has a lower activation energy. Lowering the activation energy will only increase the number of effective collisions. The number of total collisions will not be affected. Here, let us consider one important thing. Catalyst never involves in a chemical change, but it will provide a way or a path for the reactant molecules to convert as products by utilizing least energy. Collision theory. This theory are also called as collision theory of bimolecular reactions. According to this theory, the kinetic molecular theory may be used to explain how the various factors will affect the rate of chemical reactions. Here, that means previously we have discussed about six factors. Those are comes under kinetic molecular theory. As per collision theory, as the particles in the reactants move around, they collide with each other. Most collisions do not result in anything, but a few will cause the bonds in the exciting molecules to break apart and new bonds will form to make new molecules. Simply, we can say that all collisions are not able to bring chemical change. A few collisions only will cause a chemical change. Collisions that result in the formation of products are called effective collisions. Repeating again, collisions that result in the formation of products are called effective collisions. The idea of effective collisions is called the collision model and states that the rate of a reaction is affected by number of effective collisions between reactant molecules. According to the collision model, the rate of reaction may be increased by increasing the number of total collisions by increasing the number of effective collisions by decreasing the activation energy. I am repeating again. According to the collision model, the rate of reaction may be increased by increasing the number of total collisions or by increasing the number of effective collisions by decreasing the activation energy. Arrhenius created a mathematical relation between the rate constant and the temperature. This equation is called as the Arrhenius equation. So here we can see the Arrhenius equation. Here A is equal to frequency factor or Arrhenius factor, EA is equal to activation energy, R is equal to gas constant, T is equal to absolute temperature. Number of collisions per second is said to be collision frequency. This can be denoted by Z. Then we can modify Arrhenius equation as follows. K is equal to ZA e power minus EA by RT. Number of collisions with proper orientation is said to be probability factor. This can be denoted by P. Now again we can modify Arrhenius equation as follows. That is K is equal to PZ A to the power of minus EA by RT. These are the important postulates of collision theory of bimolecular reactions. Thank you. Happy learning.